Now an equation of the form PV to the power n is equal to constant. Okay, so in this equation n is a constant that can be used approximately to describe many processes which occur in practice. Such a process which follows this mathematical equation is called a polytropic process. It is not adiabatic, but it can be reversible. So it is a very important point that you must note down, that a polytropic process is not adiabatic. It is not adiabatic, okay, but it can be reversible. So this is quite an important point that most people would get confused in. Alright, now it may be noted that if you talk about the adiabatic process, okay, so the law that governs it is PV is equal to PV to the power gamma is equal to constant. So the value, that is gamma, which is the adiabatic index, it is a property of the gas, whereas this constant, which is n, it is not a property of the gas. Okay, so the value of n, it depends upon the process. Okay, so let's mark this as point number 2. So gamma, that's a part of the adiabatic process. Okay, so this depends upon the property of the gas. Okay, n does not depend upon the property of gas, whereas n depends upon the process. Depends upon the process that is taking place. So for every you can say process, you will have a different value or a unique value of n. It is possible to find the value of n, which is more or less the experimental result. So if you talk about two states, or let us say a process which is going from state 1 to state 2. Alright, so this is happening, and this is a polytropic process. So I would say this law is true. So P1 V1 to the power n is equal to P2 V2 to the power n. Okay, so I can say that V2 by V1 whole power n, this is equal to P1 by P2. So let's take log on both the sides. So when you take log on both the sides, you'll have n into natural log V2 by V1. This is equal to natural log P1 by P2. Now from this I can say that the value of n is equal to, now this P1 by P2 can be changed to log P1 minus log P2, and the denominator would now become log V2 minus log V1. So this is an expression or an equation that can be used to find out the value of n, that is the polytropic index. Okay, so if I know the values of P1, P2, V1 and V2, n can be calculated, or correctly speaking, it can be estimated from the relation in front of you. Okay, now there are two more relations of a polytropic process. Okay, so let's talk about them. So the first relation that you should remember is T2 by T1. This is equal to V1 by V2 to the power n minus 1. Okay, and this is equal to P2 by P1 to the power n minus 1 by n. So these two expressions are also very, very important for a polytropic process. So this was a very short analysis on the polytropic process that occurs when you use an ideal gas during a process. Okay, and we came to know that the polytropic process can be reversible, and n, that is the polytropic process index, it does not depend upon the property of the gas, but it is dependent upon the process which is going to happen. All right, and then we looked at two expressions, or rather three expressions, that help us to find out the values of N and the relation between temperatures and volumes at the two states. Okay, so now in the next video, let's talk about the entropy change in a polytropic process.